This video will describe how to use Onset's Dissolved Oxygen Data Assistant software tool with the HOBOware Pro software. The Dissolved Oxygen Assistant is used to correct for measurement drift from fouling in the field. It also gives you the ability to calculate salinity adjusted dissolved oxygen concentration as well as percent saturation data. Again, if you are in a saltwater type application, you can adjust the data for changing salinities. You can also put in a barometric pressure, either a value or use a barometric pressure data file to calculate percent saturation. So what we have here is we have a data file we've offloaded from our U26 dissolved oxygen logger, and we're going to run through the Dissolved Oxygen Assistant for you. So you can see here our plot setup screen. The raw data that's recorded is dissolved oxygen in milligrams per liter or in parts per million. And again, our temperature is either in degrees F or C. If you're using if all you care about is DO concentration in a freshwater type application, you can just use this raw information, this raw data. You don't have to post-process the data. However, if you need to compensate for changes in salinity, or if you want to get percent saturation, you need to run through the assistant. As we've seen before, growing degree days also shows up as an available data assistant. That's because there is a temperature channel involved. HOBOware, anytime it sees temperature, HOBOware Pro, if it sees temperature, it makes the growing degree days assistant available also. But we're going to select the dissolved oxygen assistant here. So we clicked on process and we get the dissolved oxygen data assistant to appear. Starting up in the left-hand corner, if this particular deployment was in salt water, you want to adjust for changes in salinity. This particular deployment was actually in salt water. You have two different ways to adjust for salinity based on either a salinity measurement or a specific conductance measurement. If you're in a situation or a deployment where the salinity is not changing, or if the specific conductance is not changing, it's fairly consistent, you can use either one of these as a fixed value. Salinity, again, is in parts per thousand, or what they call PSUs, practical salinity units. Specific conductance can be in either microsiemens per centimeter or millisiemens per centimeter. You get that again, you can get salinity or specific conductance from our U26-001 DO product, or you can use a third-party salinity data file or specific conductance data file and import that into HOBOware Pro, as long as it's formatted correctly according to the formatting procedure or formatting guidelines that are spelled out in the HOBOware Pro User's Guide. For this example, we're going to use a salinity data file, which we have. It's a U24 data file, U26-001 DO. So here I will select my U24, my raw U26-001 data. You could also post-process your U24 data to get salinity using the conductivity assistant. Using the post-process data from the U24 gives you the best accuracy because you have the ability to calibrate that data for drift over that deployment. With the raw data, you don't. But for this exercise, we'll just use the raw data. So we'll click on Open, and now you can see that it's associated with this adjustment for salinity selection. If you want to calculate percent saturation, you need to compensate for changes in barometric pressure. We give you the ability to put in a single value here, or you can associate it with a barometric pressure data file during your that happened during your deployment. If you are again, we're going to use a barometric pressure data measurement from one of our data loggers, specifically the U20 water level logger that was deployed in air during that deployment. You can also use a third-party weather station barometric pressure file if it's formatted correctly according to the HOBOware Pro User's Guide. However, keep in mind that if you get that from a weather station like the National Weather Service or one of these other services, that will be corrected to sea level. So you need to use this checkbox and put in your elevation in order for that to be accurate. Below that, we see we have the ability to create or adjust our resultant series names. By default, our adjusted concentration will be called DO adjusted concentration, and percent saturation will be called that. You can change that if you want to. You can also put in user notes, and those will show up in your details pane. Moving to the right, here is where we select how we want, or if we want to do a field calibration on this device, and if so, what field calibration method we want to use. When you do a lab calibration, when you replace a sensor cap, that calibration will remain accurate for the full 6-month life of the sensor, provided there's no fouling of that sensor. Typically, most of your deployments you will get some fouling. So this is where field calibration becomes very useful, because you can compensate your data for that, or correct your data, I should say, based on some field calibration method. So what we give you is again, this is you see starting calibration point, ending calibration point. Give you the ability to put in, if you're using the DO meter or dissolved oxygen titration method, we give you the ability to enter or reference a calibrated value of DO in milligrams per liter that represent a specific data point at the beginning of your deployment and near the end of your deployment. Keep in mind that when you're doing this in the field using either method, the meter, titration, or water saturated air, you have to write down your time and date in your logbook of when you did that, so you can correlate those values to recorded data points in your logger, in your data set, or in your data file. Also keep in mind that when you're correlating those measurements, those manual measurements to data points in your data file, you want to make sure that the logger is stabilized at temperature in the water before, so that when you're correlating those numbers, that you don't get an error. So you want to make sure that your logger's in the water for at least 10 minutes when you're doing a starting calibration point. Again, you don't have to do a field calibration. However, it really does help to correct for any fouling that may happen during your deployment. So if we select using the dissolved oxygen meter method, again, we can select to not use a starting calibration point and just use our lab calibration as our starting point. So if we uncheck that, it will use that. It will not apply a starting calibration point, and then we can just put in an ending calibration point. You could also, as an alternative, you could just use the starting calibration point. However, keep in mind that if you do that, you're just using one fixed value. Again, the series will be adjusted for one calibration point. So it may be accurate enough for applications where there is no significant fouling, but it would make sense that if you're going to do it, you want to use both, or at least an ending calibration point, so that you can effectively compensate for changes or correct for changes in the measurement due to fouling. For our deployment, we had a meter. We had a calibrated dissolved oxygen meter, so we were able to take measurements and write those down in our logbook. So what we're going to do is these are all our data points in our data file, and we're going to correlate our meter reading to a specific data point during our deployment. So our starting point was at 5 p.m. and it was 8.12. And our ending data point was at 2:30 p.m. on the 11th, and our ending data point, our ending calibration point was 7.89. And again, we had a meter. We took a sample of the conditions at the time. If you wanted to use the 100% water saturated air using the cap and the sponge with fresh water, you could do that. Keep in mind that you need a barometric pressure value to enter to correlate with this same time. Again, you can do that with a meter if you have one on hand, or this from the left selection it means it's going to take that barometric pressure data from whatever you selected over here. So if you put in a single value, it will use that. If you're using a barometric pressure data file, it will use that. Same with the ending point. For our application, we use the dissolved oxygen meter. The other selection is to check off to only report data between the selected points, meaning you're only going to see data between the calibration points. You're not going to see data outside of those points. One other note about the dissolved oxygen assistant, in fact, all the data assistants, is these values that we put in here stay in HOBOware. Again, it's just retained until the next time you use it, and then you have to go in and change it. Again, not specifically the data file data points, but these values, the meter or titration values, or the barometric pressure values, whatever. So if you have multiple loggers that you want to use those same values for, those same measurements, they'll still be in here. You don't have to keep re-entering them. They're not blank. But just keep in mind that if those values are different, you'd have to make sure that you change them so that your data is accurate. So let's click on Create New Series to get into the plot screen. We're getting basically a message window that says the salinity or specific conductance data in the selected file ends before the end of the dissolved oxygen data. This means that we have some overlap. So we have our U24 was deployed for a longer period than the dissolved oxygen data. So again, it gives you two different choices. One, you can choose to generate the resultant series data only where the two data sets overlap. That would be my suggestion. You could also just apply the last salinity value to all the oxygen readings after the end of the log salinity or specific conductance data. But I like option 1, so I'm going to select that. And now we're back in our plot screen, and you can see here's my raw dissolved oxygen concentration again, my temperature, those are my raw measurements. In blue, we see my new dissolved oxygen adjusted concentration based on that salinity adjustment. And again, we can plot that in milligrams per liter or parts per million. We also get dissolved oxygen percent saturation because we did that. We put in that barometric pressure data file. Below that, here is the high range conductivity coming from the U24 data file that we decided to use, and the absolute pressure, which is the barometric pressure we're using from our U20 file. And we can uncheck these if we're not interested in seeing them plotted, but we'll plot them just to have a look. So here is our data. You notice these series there's nothing in them because our barometric pressure logger started logging before the DO logger, so we can scroll down through the data, and here we go. There's where all our data is. And again, we can see that they weren't exactly coordinated as far as their launch times were concerned. That's what this is saying. That's what our warning was saying. Here's my DO. Here's my conductivity. There's my adjusted concentration in milligrams per liter and my percent saturation based on my DO assistant post-processing. Again, if we want to see what parameters were used in the DO assistant, we can click on one of the derived series and go down, and you can see dissolved oxygen assistant parameters. Click on the little plus sign, and there's all the information from what was used and what was entered when we were post-processing that data. Once we are happy with how this is plotted, we can save it as a project file. If we don't save it as a project file, the next time we open the .hobo file, the U26 raw data file, none of these parameters, these calculated parameters, will be retained. We have to save that as a project file in order to retain them. So we click on File and say Project. If we want to export it to Excel, we click on Export Table Data, and the data is exported in the format that we set in our HOBOware preferences.